This video has good news and bad news. We'll start with the bad news, I think. I don't know. Example 5, what's the derivative of this function? Now we have sum and difference rules. We can just add, we need to take the derivative of two things added to each other. We just take the derivatives individually and add them together. But what kind of a function is this? This is a quadratic function. You FOILed it all out, you would get a quadratic function. But if you took the derivatives individually, the derivative of this first guy is just 1. The derivative of the second guy is 1. So if we multiply their derivatives individually, we get that the derivative should be 1. But that doesn't make sense. The derivative is a slope function. The slope of a parabola is not just always 1. And that's the bad news. The bad news is that if we have two things multiplied by each other, we can't take the derivatives individually. Can't take derivatives individually here. And that's true for multiplication and division. You probably expected that. Why else would we have a video that talks about product and quotient rules? And that's the good news. So there's a workaround here. We could rewrite our function by foiling. First, outer, inner, last. F-O-I-L, FOIL. And you'll get that x squared plus 5x plus 6 is our function. And we can use the power rule to get that our derivative is 2x plus 5. And it turns out that the derivative of a parabola is always a line. The slope of a parabola can be found by looking at different values on a line. So we got the derivative. Well, now we get to example 6, of course, and well, what is the derivative of this function? Well, yeah, we could multiply it all out, do this pairing and this pairing and this pairing and this pairing and then this 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 and this. Okay, right. Nobody wants to do this. That's the good news. But this is not the good news, but the good news is that we don't have to. Okay? There is a product rule. We don't always have to multiply things out. We're going to use the product rule, which I'll tell you right now. The product rule, pretty nice. Not amazing. Not as nice as we might want, but pretty nice. The quotient rule, let's focus on the positives here. So the product rule says that if I want to take the derivative of two things that are being multiplied by each other, it's not as easy as we want. We would like, right? This is what we'd like, but it's not. Basically, it's we take the derivative of one of them at a time and add the results together. So usually how I say it is the derivative of the first times the second plus the first times the derivative of the second. Okay? The idea is, yeah, we take the derivative of one, leave the other alone, switch it up, add the results together. Wondering where this comes from? Feel free to ask me about it one day. I'll show you. But I'm not going to spend time showing it here. Comes from the definition of the derivative, though. Quotient rule is less nice. Okay? If we have one function divided by another, it's kind of similar to the product rule, but now it has a minus. Okay? And then we also have to divide by the square of the bottom. Kind of weird, but it's true. Also, there's a couple of different jingles that people have made to remember this. One of them is like saying, it's not really a jingle, but it's like a little rhyme. One of them is low D high. That's the start of it, which means the low function times the derivative, D for the derivative of the high function, right? G is on bottom, F is on top, so G is low, F is high. Low D high minus high D low. Doesn't fit. high d low top function times the derivative of the bottom function. Square the bottom. That's g squared. And away we go. How fun. Because you got to simplify after that. So you can use your notes or you can remember this. This is literally what I use to this day. This is how I remember it. I never remember it this way. All right. And every time I teach this class, every time I do derivatives, I say that in my head. Low d high minus high d low, square the bottom, and away we go. Anyway, find the derivative of this function, f of t. All right, well, notice first that we do have two functions being multiplied by each other. This is the derivative of an f times a g. So we know by the product rule that this derivative, which is a t, is going to be f prime times g plus f times g prime. That's what the product rule tells us. And a lot of times, especially for more complicated functions, it can be helpful to write these off on the side. What is f prime? What's the derivative of an exponential function? We'll go all the way back to the beginning. Doesn't matter what variable you have, the derivative of an exponential function is itself if the base is e. Well, that's really, really nice. The derivative is itself. What's the derivative of a logarithmic function? The reciprocal. So again, on your formula sheet, you have the derivative of ln x is 1 over x, but we have the variable t, so it'll be 1 over t. And now we just plug everything in. F prime of t is f prime, which is e to the t, times g, which was natural log of t, plus f, which was e to the t, times g prime, which was 1 over t like so. We can clean things up a little bit by factoring out an e to the t from both of them. And we're left with the natural log of t plus 1 over t. And there's no more simplifying that can be done. That's the derivative, and that's how we can use the product rule. Next one has us practice with the quotient rule. We're going to do the same thing. Here's our f. Here's our g. What's f prime? We'll use the power rule. It's 4x cubed. What's g prime? We'll use the power rule. We need to find the derivative of 3 and the derivative of 16x cubed. Remember, the derivative of any constant function is just 0. And now we can use the power rule. 3 comes down. 3 times 16 is 48. I'll write it. 16 times 3. And then subtract 1 from our exponent. And we do get that g prime is 48x squared. Now we say that y prime will use the jingle. Low d high, or in this case d high times low, minus low d high minus high d low, square the bottom, and away we go. Oops, I should use blue for that. Now we just plug in and try to simplify if we can. These ones are usually messier to simplify. F prime is 4x cubed times g, just 3 plus 16x cubed, minus f, which is x to the 4th, times g prime, 48x squared, all over g squared, 3 plus 16x cubed. As a general rule of thumb for rational functions and simplifying fractions, you may or may not be familiar with this, but a rule of thumb for simplifying fractions is to expand the numerator and collect like terms. Then factor again. The denominator, just keep it factored. So in this function, when we want to simplify it, the bottom, which, sorry, has a squared here, the bottom will keep, we're not going to expand that out. There's no reason. But the top, we will want to expand it out so we can collect like terms and factor. So when we distribute that top, we're going to get 12x cubed plus 64x to the 6th. And then minus 48x to the 6th, like so. The denominator we leave factored. And look, we can combine like terms. We expanded the numerator, great. Now we will collect like terms and then factor again. So we'll get 12x cubed. We have plus 64x to the 6th, and we're losing 48 of them. There's only 16 left. I did not give myself enough space again. It's been too long since I've done the quotient rule, like a year. So what we're going to do is now factor the numerator. We can factor out a 4 and an x cubed from the numerator. We're left with 3 plus 4x cubed. And our denominator, still 3 plus 16x cubed squared. And they look kind of similar, but we can't cancel or simplify unless they have a same factor. Gosh, this citing makes it hard to see. We got a fraction bar here. Nothing else to simplify here. The simplifying is not the big thing that I care about right now. The big thing I care about is just getting to here. This is where most of the points are. And then like 1 point for simplifying or something like that. All right. Well, this is our product tool. We got more of this later on. The next video, we're going to pause and look at some homework problems. And then we got more practice with the product and quotient rules in the video after that. All right. So this is where we're going next. And then we got more stuff after that. Let me know if you have any questions. Bye-bye.